Okay, so this is looking at from the chapter review, question 1, part B, and question 1, part D. So the directions here ask us to eliminate the parameter and find the domain and range of the resulting rectangular function. So we have that x is equal to 1/4 t, and then y is equal to 2t squared minus 5. And we'll get back to the range for the interval for the parameter there. So first thing I'm going to do is solve the equation for x in terms of t. So I'll multiply both sides by 4. And then I'm going to just substitute this into the equation for y. So I've replaced the t with 4x squared. And then 4x squared is 16x squared. When I multiply by 2, I get 32x squared minus 5. So there is a rectangular function. So the next step is to identify the domain and range for this. So the domain is quite easy since the x function is linear and the interval for t is all real numbers. Well, a linear function, if you plug any real number in, you can get any real number back out. So I know that x is also all real numbers, so the domain is also all real numbers. Now we're going to turn our attention to the y. So y here is a quadratic. So if you put any real number in for a quadratic, you're not going to be able to get any real number back out. So remember, like a quadratic looks like a parabola. So what I'm looking for is what the range for a function like this is. So if I look at this, since the leading coefficient is positive, I know this is a parabola that opens up. So what I need is this lowest point on the parabola up to positive infinity. So to find this, I need to know what the vertex is. So for the vertex of a parabola, the x-coordinate is always negative b over 2a. And when we say negative b over 2a, we're talking about the a, b, and c as the coefficients for our parabola. So if I go back and look at this parabola here, the a is 2, the b is 0 because we have no regular x term, and the c is negative 5. So in our case, the x-coordinate for the vertex is just going to be 0. Since it's going to be negative 0 over 2 times 2, that just becomes 0. And when I plug that in to this equation to get the y-coordinate, I'm going to plug 0 in for t squared, which is going to give me 0 minus 5, or negative 5. So what I have then is that my range is negative 5, and that should be a bracket, to positive infinity. Which again, if I went and looked at the graph of this guy, should match up. And let's do that real quick just to kind of confirm what we did algebraically. So let's turn all that stuff off. We should be in function mode because right now what we're graphing is just a function. We don't want to be in parametric mode. So I'll do 32x squared minus 5. And notice my window's all janky here because I was doing something in another class. So I'm just going to hit zoom standard to get me back in that normal negative 10 to positive 10 window. So if I look, what I have is a parabola. And it looks like its lowest point is here at negative 5. And it's pointing up, so it's going to positive infinity for the range. So I'm quite certain that this is correct. Let's look at part D. Part D is a little bit different because here you'll see that the interval for our parameter is restricted, right? It's not simply all real numbers. But we're going to start the same way. Except this time, what I'm going to do is I'm going to solve for t using the y equation. So just multiply both sides by -2. And then I'm going to plug into the x equation. Everywhere there was a t, I'm going to put a -2y. So that's going to give me 8y squared plus 4. And now if I want to get this in terms of y equals, I'm going to subtract 4 from both sides and divide both sides by 8. And then we'll square root both sides, so we get y is plus or minus square root x minus 4 over 8. And I think on the review I had this written in a slightly different form. So just to show you that the forms do match, what I did here was I thought about 8 as the square root of this as two things, and the square root of 8 is just 2 square root 2. So we could take off the 1/2, and then underneath have the square root of x divided by square root of 2, so that's just going to be x over 2. And then I have square root of 4 divided by 2, which is just going to be -2. But this would be okay still for me. Either of these would be okay as far as I'm concerned. Next we need to get the domain and range. So the range in this case is going to be the easy one, because notice the range is a linear function. So all I need to do is to plug in these values for t. So when I plug -1 in, I get y equals -1/2 times -1, which is equal to 1/2. And when I plug positive 4 in, I get -1/2 times 4 is -2. So my range is going to be the y's going from -2 to positive 1/2. And now we do have to be a little bit careful here, because notice the interval for our parameter up here. One of these endpoints has a parenthesis and one has a bracket. So the -1, which gave us a 1/2, needs to have a parenthesis on it. It needs to match the interval of the parameter. And the -2 that came from the 4 needs to have a bracket. Again, it needs to match what's on that interval for the parameter. So there's my range. For my domain, what I need to do now is look at my x. So again, there's going to be 3 values that I'm concerned with. I'm going to be concerned with each of these 2 endpoints as well as the vertex. So for here, the vertex happens, again, when t is equal to 0. I'm using the same explanation that I used over here. And when I do that, I get 4. So I have t equals 0 that I need to check. I need t equals -1 and t equals 4. So when I plug t equals 0 in, I get 4. When I plug 4 in, I get 16, 32, 36. When I plug -1 in, I get 1, 2, 6. So I'm going to go from the lowest to the highest. So it's going to be 4 to 36. Notice that the 4, or the 36, comes from the 4, which comes from that 4, which had a bracket on it. So the 36 is going to get a bracket on it. The 0, or the 4, comes from the 0, which is inside this interval, so that also is going to get a bracket. So that is my domain then for this one. I hope that helps.